Hello viewers, I am Dr. G. Littlefla, faculty from the Department of Physics, Stella College, Vijayawada. I feel so happy to welcome you all to another interesting topic on fundamentals of optical fibers. Optical fibers have become the backbone of global communication systems, from high-speed internet to long-distance calls, and they find applications in many fields. The data given to the optical fibers will be transmitted at the speed of light with minimal energy loss. The way they transmit with high precision, reliability, and security has transformed the ways in which we share information, and these optical fibers have connected all of us together and provide us limitless opportunities for innovations. So with this brief introduction, let me narrate some fundamentals. So this picture depicts a bundle of optical fibers. What are called optical fibers? Optical fibers are waveguides in which light energy is transmitted with minimal energy loss. Waveguides means tubes, thin transparent tubes in which the light waves will be guided to travel from one end to the other end. So they are very thin. And they are very flexible. They are made out of glass or plastic, and they are drawn into thin strands whose diameter will be little higher than the thickness of the hair. The principle of optical fiber is that when light is sent into the optical fiber at a certain angle, it undergoes total internal reflection. You could see here the light fed to the cable. Here it gets totally internally reflected. So it undergoes multiple total internal reflection and comes out at the other end of the cable with minimal loss in its signal strength. Basic structure of optical fibers. From the picture we can see the innermost layer in which we allow the light to travel, that is called core. The next ring surrounding the core is called cladding. Then we have one more enclosure which is called buffer, and all these three together is inserted or enclosed in a jacket for protection. So core is the innermost part of the optical fiber through which the light signal travels. Generally, this core is having higher refractive index, and this cladding is the surrounding layer of the core. Its refractive index will be lesser than the core. And we have a buffer. This buffer is nothing but a coating or a layer surrounding the cladding for safe environment. All these three together will be enclosed in a jacket. So the total 1, 2, 3, 4 together we call it as an optical fiber. So the outer jacket provides mechanical strength to the optical fibers. So the core is made of glass, high purity glass, usually silica or plastic. Even the cladding will also be made out of glass or plastic. Core's refractive index will be very high. Cladding refractive index will be lesser than the core. Additional layer is called buffer. This is also made of plastic, which protects the fibers from physical damage or moisture or any other environmental factors like temperature or electromagnetic interference, etc. So another picture I bring here. The first one says that the innermost part is called core, its refractive index is high. The core is surrounded by a layer called cladding. Its refractive index will be lesser than the core, so that total internal reflection could take place. If we cut the optical fiber cable, we can see the structure like this. This is the core, the orange part is called cladding, and the next layer is some coating followed with a jacket. And in this picture, exactly what's happening we can see. Using LED or laser diode, we allow the light ray at certain angle and allow it to enter into the core of the optical fiber. So the light ray sent by the LED source or the laser diode, the light ray at certain angle, it is allowed to enter into the cable. So it undergoes multiple total internal reflections and comes out at the other end, where with the help of the receiver, the light ray can be received and data can be retrieved. So this is a optical fiber. Innermost part is core, the blue is cladding with coated, having an outer coating, and these three will be inserted into the jacket. Now using LED light source or laser diode source, the light energy is allowed to enter into the cable at certain angle. This light ray meets the boundary between the core and the cladding. As the refractive index of the core is more than the refractive index of the cladding, the light ray undergoes totally internally reflected multiple times along the cable optical fiber, and it comes out with the help of the receiver. We can receive and retrieve the data. Now, what is total internal reflection? The same thing with better clarity I have provided here. Total internal reflection takes place between two media. So when the light ray travels from higher refractive index region to lower index region, total internal reflection takes place. So the light fed into the core, we know the core is having higher refractive index than the cladding. So due to that, when it is striking the boundary between the core and the cladding, it is totally internally reflected, and it goes and meets the boundary between the core and the cladding here. Again it undergoes total internal reflection. Multiple way it is coming out. So this is what called total internal reflection. Now optical fibers based on material composition. So the optical fibers can be made of glass or plastic. Mostly silica is used for making glass optical fibers. In this glass optical fibers, both core and the cladding will be made of glass. Sometimes, this glass optical fibers have special features. They have high quality transmission with a minimum loss. High quality transmission with minimum loss, and they are suitable for long distance and high speed communications. Also, glass will not be melted easily. Very high temperature it goes. So generally these glass optical fibers are resistant to environmental factors like temperature changes and electromagnetic interference, making them highly reliable for communications. So these optical fibers are primarily used in telecommunication, internet connections, and medical equipments, and many more. So the second kind of optical fibers are plastic optical fibers. So generally polymer materials are used. The plastic optical fiber core will be the diameter of the core will be little more than the glass fibers. What are the materials used in the optical fibers for plastic optical fibers? in glass optical fibers we use silica or silica doped with some elements like germanium or phosphorus. So you get a doubt what is called doping. Doping is adding some other elements in small quantities to the pure silica so that we can get the desired refractive index of the core and cladding. So we have to add certain impurities like germanium or phosphorus to the pure silica, and the addition, how much quantity you are adding the impurity atoms, by that you can change or modify the refractive index for both core and cladding. So core, if you want to have more, you have to go for germanium atoms, and if refractive index you want to reduce, you can have some other element. Let us see here. So what is the use of this glass? So in glass optical fibers and all, the signal undergoes low attenuation and the glass fiber itself high strength, and they are resistant to heat and environmental conditions. Now for plastic polymers, we use polymers, especially polymethyl methacrylate for the core, and another polymer which is fluorinated for cladding. So for plastic optical fibers, for the core we use PMMA, that means polymethyl methacrylate polymer, and for the cladding we will be using fluorinated polymer. And this plastic polymers, plastic name itself tells that it is very lightweight. So it is much cheaper than glass, because glass to prepare you have to heat them to more than 1000 degrees Celsius and all, whereas plastic, that much temperature is not needed. So manufacturing glass is costlier than manufacturing plastic. So the manufacturing cost is lower and greater flexibility. The fibers can be bent or turned around, greater flexibility than the glass, but the drawback is that they have higher signal loss. So we can use plastic optical fibers only for short distance communications or applications, whereas glass optical fibers are used for long distance communications. Now dopants, I already mentioned. Dopants are the impurity atoms which are added in certain quantities to the silica glass, because both core and cladding are made out of silica, but the impurity atoms quantity decides the refractive index, and it decides which can be used for core and cladding. So here mainly the dopants, suppose if you want for the core we need a higher refractive index. So if you want to increase the refractive index, you have to add the impurity atom germanium to the silica glass. And if you want to lower the refractive index, in the case of cladding, you need to add boron or fluorine to the silica glass, so that we can prepare both core and cladding. Now what is called attenuation? So in that cable, when we send the light ray, that light ray should not be distracted. It should go as such and come out of the cable without any deviation. This is what called attenuation. Or there should not be any signal loss. With what intensity you are sending the light ray into the optical fiber, at the end of the optical fiber it should come with the same intensity. So the signal strength should not be lost. Why it is getting lost? Because the glass or the plastic optical fibers can absorb a little amount of light, first thing. So signal strength gets lost there, and then maybe a little part can be refracted and go. So all these things should not take place. Usually when they design the optical fiber, all these will be taken into account. So the gradual loss of signal strength as light travels through the fiber, this is what called attenuation. So while they design the optical fiber, they see that they have low attenuation. So mainly absorption, scattering within the core. When the light is guided, the light certain amount can be absorbed by the cable and then the light could undergo scattering, or it could refract and get out of the core if it is not properly designed. So by this it can lose the signal strength, but generally they are designed such a way that attenuation is kept a minimum. Now next term is called dispersion. What is dispersion? So the spreading out of light pulse. So you send a thin fine beam as the input to the optical fiber. At the other end, if it comes out as wider, spread out, that beam is spread out. So what happens? There are optical fibers where only one signal can be sent. There are multiple mode optical fibers are there where many signals could be sent. So if the input light, the fine beam, if it undergoes dispersion, it overlaps with the other signals and we lose the clarity of the signal what we have transmitted into the optical fiber. So by attenuation we lose the signal strength. By dispersion we lose the clarity of the signal. So single mode fibers have lower dispersion while multi-mode fibers can suffer from higher dispersion over longer distances. So single mode have lower dispersion, which is very much good for communications. Multi-mode optical fibers, if you take where multiple ways. See the optical fiber, it is a surprise to know that a single optical fiber can carry 3 lakhs voice signals at the same time, and the 90,000 TV channel signals a single fiber can take. Okay, the fiber is so small, very fine, but it could carry that much data through it. So multiple mode fibers for long distance transmission may not be that much useful because it has a lot of dispersion, whereas single mode fibers will have low dispersion suitable for longer distance communications. Now first of all, what's happening in the optical fiber? What is that light ray, why to send the light ray through the optical fiber? All the question comes. Actually what happens in our surroundings, in our environment, a lot of data has to be gathered. For example, at the traffic point, the traffic police would be interested to know the speed of the vehicle which are crossing, which are traveling on the roads. So are there, or some other places we want to know the temperature, pressure, force, and with what speed the vehicles are going, all that to be noticed. So they keep sensors everywhere accordingly. For measuring the speed, one kind of sensor; for acceleration, another kind; for force, another kind; for temperature, another kind sensors. Multiple sensors are available. Though everywhere a person cannot stand and take, and these are all the things happening at random speed. So sensors will sense and collect the data. So at that place, what is the temperature? What is the pressure? So at that point, the vehicle is traveling with what speed and what is the acceleration. Every data, physical data would be obtained. Then this data will be given to the transducers. That is another device. So first sensors sense and collect the data in the environment, and transducers convert this physical parameters like temperature, pressure, acceleration, everything into electrical signals in terms of voltage and current. So transducers now converted the physical parameters into electrical data. Now what happens with it, with some other thing, what happens, this electrical signals will be converted into binary decimals in terms of zeros and ones. So if 1 is there, signal is present. If 0 is there, no signal. That is what. Now what happens? This binary coded electrical signals which is carrying the data will be converted into light energy. Okay? Light energy. So this light energy in the form of a light beam will be fed into the optical fiber. So the physical data collected by the sensors are converted into electrical signals using transducers, and these electrical signals are converted into binary form, and that binary coded information will be converted into light signals. That light using laser or a laser diode, that light signal will be fed into the optical fiber. These optical fibers are very thin, very flexible. So the light rays with the help of total internal reflection undergoes multiple reflection and reaches the other end. So at the other end we have the receiver. In one of the picture I showed, the receiver will collect the data. Now the data is in the form of light, and after receiving the light it will be converted into electrical signals in terms of binary form, and then from that we can retrieve the data. So from here to longest distance, suppose you speak over your mobile to a person in US, within no time the signals, our sound signals are converted into electrical signals, and that is converted into decimal code, and then binary code, and that is converted into light energy. So the data given to the optical fiber travels at the speed of light, so reaches the other end for long distances with minimum loss in the signal strength and so on. So that is what happening. So the data, the whole world is craving for data. This data is being shared with the different systems, people. So all this can be taken through the help of optical fiber. So now let us see some advantages of optical fibers. So high bandwidth, that means multiple mode optical fibers. If you take multiple signals, I told no, some 3 lakhs voices can be sent at the same time without any disruption. So high bandwidth and low signal loss, because the optical fibers are designed such a way that they don't absorb the light, they don't scatter the light, and the refractive index of the core is higher than the cladding, so that the light ray will not undergo bending away from the core or refracted through the cladding to the outside of the optical fiber. So no signal loss, as such it can be received at the other end. And immunity to electromagnetic interference. So complete communication is radio waves, electromagnetic waves. So our earth is surrounded by magnetic field and then electrical signals. This electromagnetic interference should not affect the data traveling through the cables. So because the cables are core, cladding, then you have coating, buffer, and then you have a jacket, so they are well protected, secured, and as such the optical fiber is very immune to electromagnetic interference. And optical fibers are very lightweight and they are very flexible. You can just turn around also, nothing will happen to the data. Now, applications of optical fibers. We study optical fibers, or we discuss about what is this, what material is used, what dopant is used, all that, because optical fiber finds many applications. We know physics has many branches. One of the branches optics. Now we have fiber optics. The optical fibers find plenty of applications. So a different branch of physics is dedicated for fiber optics. So optical fibers find applications in telecommunications, especially internet, telephone, television networks. They are more efficient. Earlier time we used copper wires. Okay, copper wires are not superior. So the optical fibers are superior to copper wires. They are carrying the signal in a more efficient way and a higher bandwidth, and they experience less signal loss. So in telecommunications, optical fibers play a dominant role to transmit data from one point to the other point. Then in medical field, optical fibers find plenty of applications. For example, endoscopy. If you take endoscopy, fine optical fiber through the nose or through the mouth, this multiple fibers kept in the endoscope will be they are very thin, no? So it could be inserted into the body through our nose or through the mouth, and it is going through. From here, the doctor could send light through the cables and illuminate the organs, and the incident light on the organs gets scattered. So the scattered light will be picked up by the other optical fibers, and it is sent back to the doctor. So doctor, from using this endoscopy, there is a microscope also, he could see what's wrong with the internal organs and could give you correct treatment. So optical fibers are used in endoscopy for internal medical examination, allowing doctors to see the inside the body with minimum invasive surgery. No cutting, no bloodshed, just inserting the optical fiber, and he could know the situation and make a decision what ways of treatment could be given, and the optical fibers can be pulled out. So non-invasive way the treatment, the diagnosis could be carried out. They are also used in laser surgeries because the optical fibers are very thin and minute. You can allow the light and it could be focused at a spot very accurately. Okay, and the treatment could be given. Then industrial applications, optical fibers as sensors. They can sense. I already told the sensors. Most of the sensors will have optical fiber support also. It could sense. It could sense the temperature, pressure, acceleration, and so many other things, and it could be converted into the same story repeats, the electrical signal, and then it could be converted into binary coded form, light energy through the optical cable. It could be optical fibers, it could be sent. Then these optical fibers could transmit data across equipment without the risk of electrical interference. So inside a big industry there are a lot of equipments. So from equipment to equipment, we can, using the optical fibers, we can transfer data. And in the military also, they use for communications inside the aircraft, ships and all, submarines. They can use these optical fibers to communicate with each other. For weapon making, everything also, optical fibers are highly useful. The optical fibers are very lightweight, flexibility and immunity to the environmental interference. So we can use these optical fibers in military, in aircraft, ships and etc. They are also used to secure data transmission, as optical fibers are harder to tap. Okay, suppose very secret information, if we speak over the mobile, can be tapped by anybody, but through optical fibers, if you send such information, very difficult to tap. So security is there, precision is there, reliability is there, and the speed is there, everything is there, and no signal loss. So optical fibers are superior. The information delivered into the cable cannot be tapped by external members. So security it is providing, and for adding light and for decoration purposes, you could see in the shops and many places the optical fiber, beautiful multiple LEDs, multiple colored LEDs will be kept. Multiple optical fibers as a bunch will be held, and when they switched on, you can see one time they bring yellow light, green light, red light, like that. So for decoration purposes, then architectural lighting, as they can deliver light from difficult point to the reachable places, because suppose inaccessible place, if you want to send the light through the optical fiber, you can send. So that unreachable part also can be illuminated. That way it is very much helpful for architectural lighting. Then for scientific research, optical fibers are used in spectrometers and other scientific instruments to transmit light over distances without losing the integrity of the signal, allowing accurate measurements. So finally, what I want to say is the data in the form of light energy can be transmitted through optical fibers at a higher speed in the reliable manner, and these fibers are durable, flexible and immune to electromagnetic interference, and make these optical fibers very invaluable in many of the modern technologies. I hope you would have enjoyed this talk about the basic informations about optical fibers, and in the next talk I shall tell the mode, single mode, multiple mode optical fibers and how they function. So I thank you sincerely for listening to me. Thank you one and all.